everybody, welcome to the video. My name is Miles Radliff, and today I'm going to be doing a flow simulation assignment for my fluids class. So what we've got here is three different types of flow that we're going to be simulating. We've got a pure internal flow, we've got a moving plate for the flow, and we're going to have a hybrid flow. It's going to be a combination of the both. So we're going to go ahead and get into it. The program that we're going to be using today is ANSYS Workbench, and on this workbench the tool I'm going to be using is Fluent. So in Fluent you can go ahead and create a geometry, or you can import geometry, but we're going to be creating some in Design Modeler. So this is the basic screen that you're going to get in Design Modeler. We're going to create a quick sketch, so we're going to say XY plane, and we're going to create a sketch. So first thing we're going to do is units, go to millimeters. Now, there we go. Use the scale on the bottom to kind of judge how big you want your stuff to be. Always go undersized, because when you go to the dimensions, general dimension, this guy, and this guy. So, this dimension. So, I'm going to bring a dimension over here. This is my horizontal. It's going to be 200 and 10. So that is going to be the basis for the little pipe that I'm creating today. So I can't do anything with it yet. So exit out of that. We're going to do a box selection. I'm going to select everything. And I'm going to come over here and say concept surface from sketch. So it's got everything selected just like I want, and we're going to generate it. And that's all that I need to do for the geometry, so we can close out of that, and we can move on to the meshing. So here's the basic meshing console. You can see it automatically loads in my geometry. So what we're going to do first is we're going to just let the computer do whatever it wants to do, and we're going to see how bad this mesh is. So mesh, insert, method, and we're going to click this piece of geometry, and you're going to see the apply button. So apply that selection to it, and go. Generate me a mesh. Terrible. So, we're going to go in and we're going to create our own mesh by sizing our nodes. So we're going to come here, edge select. I want this guy on it, and I also want this guy, so we're going to add that to it. I need to make it hard. And I don't want it to be based on the size of the division. I want it to be a number of divisions, and I want these to have 100. So that takes care of those two surfaces. They're going to be the same. I'm going to grab this one more time, apply that, and hard, not by element size, but by number of divisions. I'm going to say 500. On to the meshing. So you can see this is the mesh that it comes up with automatically. It's not the best. It's good around the edges, but then in the middle you get all of these voids, and you lose a lot of resolution. So we're going to up that a little bit, and we're going to give it a little bit more control. We're going to say insert face meshing. So what face meshing is going to do is it's going to say, I want control over the face of this mesh. Select it, apply, done. And there's our mesh. It looks like black, but when you scroll in you can see just how much finer it is. So every one of these vertices is going to be a data collection point. We're almost done in the meshing. Last thing we're going to have to do is we're going to have to go back to our edge select, click that, and say create named selection. This one is going to be our inlet. This is going to be our outlet. This is going to be the bottom. This is going to be the top. So that's everything for the meshing for the time being. Close that. So before we get into the setup, we do have to update our mesh. So in the meshing console, the first thing you're going to get is this quick launcher. We're going to be two-dimensional. We have to be in double precision. It's just going to give you better results, and we're not doing any parallel processing. So we can go ahead and start the console. So now we're in the setup console, and you can see we've got our geometry here. If you zoom in all the way, you can see that it's actually the mesh. what we're going to look at first is this tasks page. We are incompressible on this assignment, so we are going to be pressure based. This is what we're going to leave everything as. So first thing we're going to do is we're going to come over here to the physics and check our operating conditions. We're operating at sea level, so we're going to do 1 atmosphere, 101,325, and we're going to come over here to models, viscous, laminar. Under materials, fluids, air. So we're going to get to define air a little bit, right? So we're going to change our density to 1, and we're going to change our viscosity to something that's going to give us a good laminar flow without developing too quickly. So we're going to do a Reynolds number of about 1,000. For us to get that, we're going to do 0.0001. So we're going to select change and create, and then close it. So that takes care of the air. So it's smart enough to know that this is going to be a velocity inlet. Let's say we're going to give it 10 meters per second. We're going to check the outlet. We don't want to be governing the velocity of the outlet. We need to be governing the pressures. So smart enough to know it's a pressure outlet. It's just going to be 0 gauge pressure. So last thing we're going to do is the walls. So starting with the bottom wall, we just need to make sure that it is A, stationary, it's not moving, and then B, it is a no slip condition. So satisfies those, that's fine, and we just need to be making sure the same thing for the top wall. Again, stationary, no slip. Sounds good. So now that takes care of all of these basic guys. We're going to come down to initialization, initialize it. Initialization is done. Run the calculation. So this is going to be a maximum number of iterations. If it doesn't converge within 500 iterations, it probably isn't going to converge. So let's go ahead and calculate that. So there we go, about 50 iterations and we're complete. So that calculation just set up all of the numbers and everything that we're going to go retrieve from the results page. So check, the solution has been checked, and so we're going to go straight to results. So the first thing you're going to get when you come into the results page is it's going to be just the plain two-dimensional sketch geometry, no surface or anything. So what we want to do is we want to see the velocity contour lines. So we're going to come in here and we'll say a contour. Velocity contour. So I want it to be velocity in the x direction, so we're going to choose velocity u. And I don't want 11 contours, I want 100. So if you apply that, here's our velocity contour. So you can see it starts out very lowly developed and then moves on to being more and more developed. This guy is in the way, so we're going to go ahead and move that. Default legend view. Appearance, so I'm going to make these 0.02. So make the text a little bit smaller. Make it decimals, accurate to the second place. And I want it to be horizontal and centered. There we go. So now that I've got that, I'm going to move this guy up into here. And I'm going to grab a screen snip. And we're going to start pasting some of this stuff in here. So one of the other things that's going to be helpful to have is going to have these individual velocity contours at these points of interest. So I want to see it develop as it goes through the pipe. So I'm going to create a chart. But for me to do that, I'm going to have some points that I'm taking this information from. So we're going to say, in here, we're going to say insert, location. I want to take a point, and we're going to call this L1. So L1 is going to be at 50 mil in, so 50 millimeters in, 0.05. So XY, XY. 0.05, and 0.01. So starting out with only 10 samples, that's not going to be enough. I want to be able to get a very smooth curve, so I'm going to change it to 100 samples. So you can't see it, but if I uncheck this velocity contour, it's going to put it here. So we're going to rinse and repeat, and we're going to keep doing that. Okay, so that's our last line. I got one at 50, 100, 150, and one at 200. So that's it for the lines. So now I can bring this velocity contour back, and now I go create a chart. For me to do that, I'm going to go in here, I'm going to say velocity profile. So it's going to be an XY line. I'm going to call it profiles. Yes. In the data series, this guy I'm going to call L1, and it's going to have L1. Okay. Couple things we're going to have to do here. If I just plot it, it's going to do weird things. So for the x-axis, I need it to be the velocity in the u direction, and then for the y-axis, I'm going to scroll down and get y. I don't want it to do this automatically because it always gives a little bit of breathing room, 0.01. So we're going to go ahead and just do it by ourselves. And that's the velocity profile lines. So you can see moving from least to most developed, it goes 50, 100, 150, 200. We're going to go ahead and grab a screen snip of this guy, pop it in here, and they both fit on the same page, which is pretty nice. So now we're going to go through onto our second scenario, and we're going to create the moving plate. So we're back up here in the setup, and what are we going to have to change? We're just going to have to change the boundary conditions. So obviously the top wall is going to have to be a moving wall. We're going to give it 10 meters per second in the positive x direction. We're going to have to change the inlets. So what are we going to have to change? We can't just make it 0 velocity because it would block any movement of any particles in or out of that boundary. So we're going to have to change the type of boundary. So instead of a velocity inlet, we're going to change it to a pressure inlet. So it automatically pops up with this, and we're going to say reference frame absolute, and we're just going to say total gauge pressure 0. So the calculation is complete, which means we can go ahead and move on to the results. So you can see that everything that we did initially still stayed. First we're going to go ahead and grab our screen snip, and now we can go over to the chart. So in the chart, if we pull up our velocity profiles again. So what we're going to do is we're going to grab another screen snip of that. And move on to the last scenario. So back in the setup console, we're going to come back to our boundary conditions, and we're going to change our inlets. So first thing I want to do is come over here to inlet, and I'm going to change it back to being a velocity inlet. And we're going to bring it up back to being 10 meters per second. So we're back in the results tab, and you can see that we've got a different velocity profile again. So still 0 along the bottom, and then up towards the top, it's going to be like a shifted flow this time. So we're going to grab our screen snip, and we're going to grab our chart. So in the chart you can see how much it shifted, right? So like this makes sense, that at the top it should be moving at 10 meters per second, at the bottom it should be moving 0 meters per second, and in the middle it should be moving a little bit more than that because the mass flow rate has to stay the same. Put that there, and that's that. So we can throw some headers on these, but this is pretty much it for the project. Don't forget to like, comment, and subscribe, and stay tuned for the next video.